So welcome back to Notes 213. This would be part 2. Question 226, graph a line to match each description below. So we're going to start with part A right here, the line that goes up 3 each time and then goes over 5. So again, when they were describing if something's going up, they're talking about our change in y, and then goes over, in this case to the right, 5. So that's our change in x. So we're looking for a line that has a slope of 3 over 5. And then pretty much when you guys are graphing a line, I suggest you start with a point on the left side of y. Anywhere would be fine. In this case, since we have to go up 3 and then 5 to the right, I would start somewhere over here on the bottom left side, which is the third quadrant. This is the first, second, third, and fourth quadrant. So third quadrant, I'm going to start, just plot any point right there and then just go up 3 and then 5 to the right. So we're going to go up 3 and then 5 to the right. And then that's pretty much going to be your second point. And then again, remember, whenever you guys are graphing a straight line, you just need 2 points. So connect those 2 points and that's more than enough. And then just extend your lines in both directions. In example B, same thing. So this one, they're telling you exclusively what delta y and delta x is. So here, remember, it's always going to be the rise over the run, which is our delta y over delta x. And then, so they're telling us delta y is -6, and then delta x is +4. So remember that here we're going down because it's the negative tells us we're going down. So it doesn't really matter where the negative is, if it's in the numerator or the denominator of the fraction, you're still going to go down and to the right. So here it's a lot easier. Again, we have our first, second, third, and fourth quadrants. So you want to start with a point anywhere that you're going to have to, you're going to have the ability to go down by 6. So I'm going to start here in the second quadrant, which would be right there. Any point there would work. And then you go down 6 and then 4 to the right. And that would be your second point. And again, since this is a straight line, all you need is just 2 points. So make sure you connect those two. And then extend your line in both directions. For example C, it says we're looking for a line with delta y equals delta x. So pretty much that means that both values have to be equal, right? It could be any number here if you think about it. They're always going to end up being simplified to the same result. So our slope, right? Our slope is given by delta y over delta x. Now, if they're telling me that I have to use delta y and then delta x, right? I can just pretty much have delta y, and then the delta x, I'm going to replace it with what it's equal, which is again delta y. And it's just a number being divided by itself. So if those two are always going to be equal to each other, it's just a number being divided by itself, which is always equal to 1. So like I said, it could be 7 equals 7, and then a number divided by itself is always equal to 1. So a line with a slope of 1 would work on any part here. And again, you can start in the first, I would say, in the first. Here, this is one you can choose by yourself, wherever you want to start. And then let's say I'm going to start in the fourth quadrant, so down here. And then from there, I'm going to go, remember it's rise over run, so 1 over 1 is going to be our slope. So go up 1 to the right, and then again, you just need 2 points. Extend your line in both directions, and you're pretty much done. And then finally, in question D, so a line that has a vertical change of 3 and a horizontal change of 0. So meaning we're not going to move to the left or to the right. So think about the slope here. And the slope would be what? Delta y over delta x. And in this case, you substitute the values and you get what? You get 3 divided by 0. Now here again, be careful. This does not equal 0. This is what we call undefined. All right. The reason is undefined is because if you think about what a division does, is like what number times the bottom number gives me the top, right? So that's how it works. So if you think about it, actually not division there, sorry, times. So this number, the bottom, the denominator times what is equal to 3. And if you think about it, it's like any number times 0 is always going to be equal to 0, right? That's pretty much how multiplication, and it's always been true, right? Something times nothing is always going to be nothing. So here, this is why we call it undefined. All right. The reason the other one, 0 divided by 2, is equal to 0 is because, again, you apply the same principle, right? The bottom what times what is equal to 0. I know that 2 times 0 is equal to 0, so therefore that's why it works. That's why it's equal to 0. So again, the bottom one is undefined. If you have a denominator of 0, that is always undefined. So here you can pick a point in any quadrants to graph the line. All right. So I'll pick it right there, and then I can go up 3, right? And go 1 down so it fits. So I can go up 3, and then I don't have to move to the right. And if I connect those two values right there, I'm just going to have this vertical line. So this would have what we call the vertical slope. So the vertical line slope is undefined. All right, and now let's look at the next question. Zoom out. So which of the lines that you graphed in problem 226 represents a function? And if the line does not represent a function, why not? So again, if you apply the vertical line test to any of these right here, which ones would be pretty much a function? So again, vertical lines. So this one is. Second one also checks off. B also checks off. So A, B, C is also, those are all functions. And then this one is a vertical line. So this one is not a function. So again, we can say that lines A, B, and C pass the vertical line test, right? And then line D is a vertical line. So therefore, it won't pass it. Test. There we go. Now, question 228, draw a line with delta y equals 0. And how can you describe this line? So if you want to draw a line that's pretty much not changing, right? So we can draw a little x and y axis right here. So if you want a line that doesn't change vertically, so that means it's just going to be flat all the time. So you can draw a line at any part that is going to be horizontal, right? So at any moment, this is delta y is equal to 0. All right. So, and in this case, delta x, it could be just any value here. Let's call that value A, all right? So as long as it doesn't get to 0 over 0, then you're good, pretty much. So how can you describe this line? So slope of 0 is a horizontal line. And now, question B, we want to draw a line with a delta x of 0. And again, how can you describe this line? And you've seen it's the same in line D, right? It doesn't change horizontally. So this is going to be our new x and y axis. And then it's just going to be pretty much a vertical line on any part of the graph right there, going through any two cards. So we can describe this line. So an undefined slope is a vertical line. And then finally, the learning log. So describe the multiple representations web of linear functions. So again, what are the four things that we've discussed that you can use to draw vertical lines? Or sorry, to draw any functions. So what are the four things that we always describe, right? So describe how you use them right here.